Good morning. How are you? I hope everyone had a wonderful spring break. I'll just wait a few minutes to see if a few people show up. If not, I'll just go ahead anyway and you can watch it later. Let me see. All right, I'm not seeing that anyone's here. So let me post what's happening this week. It's not getting the whole thing, but that's okay. So what's happening this week is that we're beginning static charge. That means that the first assignment that you have is a static inquiry stations. Now, if we were in the classroom, that would mean that you would have different stations to go to, and you would interact with the materials there and answer some questions, do a diagram, things like that. Now, this is a video post of 9 awesome science tricks, and they all have to do with static electric charge. It will be counting as a lab grade, so you know that that counts greater than your classroom homework assignments. Um, so please get to that. If you decide that you want to work in a group with other people, you may do that. Um, each person will have to turn in their chart. Um, Actually, I don't think I'm giving a grade for the chart, but I am asking that you pick one of those 9 um, science tricks to explain it. And you're going to do that in the form of a video. I know that you guys do things like that all the time. So I'm hoping that this is something that you'll be able to go ahead and jump on and get into. Like I said, you can do it in a group with 1 or 2 other people. Um, and then you submit that video in the assignment. Okay. So you have until tomorrow midnight. That's Tuesday midnight for that. Oh, it looks like we have 2 people. Great. Yeah. Nope, 7. Looks like we have 7 people now. So please get to that. It should be fun. The video is not that long. I think it's like 5 minutes to watch all of those science tricks and then pick one that you're interested in. Like I said, you can pick a group to work in if you'd like and make a video explaining that. That means you'll have to research it to figure out what in the world is happening here. That is due Tuesday midnight. Due Wednesday, there's a close reading. We've done that in class before. You have the chart to dissect each of the paragraphs. There are 5 paragraphs in the reading. So each of the paragraphs you want to read one at a time and then go back and ascertain, okay, what's a good heading for that paragraph? What are some ideas in that paragraph that answer the focus question? I don't recall offhand exactly what that question is, but it is in the instructions on the assignment. Remember to click on the bar at the top of the assignment to get the actual instructions for it. And then you have to pick out some important words from that paragraph. They may be physics words, or they may be words that help you to explain or to understand those ideas. Um, then you have to do a paragraph, and there are sentence frames in there. You don't have to use the sentence frames if you don't want to. You can just type it in a doc. And this time I have given each person a copy of those two documents. So you shouldn't have to download them or copy them to your drive. I'm learning, getting better at this Google Classroom. I hope that you are too. Um, so that is due on Wednesday. Now we'll be back here again on Wednesday, and I will be explaining, or I'll be showing Static Cat, and then you have an assignment to do a CER on this. This should be a quick one because I've given comments that 4 students made about this, and you're supposed to pick which one you like or which multiple ones you think are explaining it best, and explain what parts you like about those and which ones you don't. So this should be pretty quick, but I would wait until after I go over it in class next Wednesday for the YouTube lesson like we're doing now. Um, so both of these are due Wednesday, but like um, this one should be really quick, and this one you should be able to do it on Tuesday, really. But I want to make sure that you spend some good time on this one. All right, and then there'll be a PhET sim. We've done the sims on computer in class before. Let me see if this is showing up here. Yeah. Um, we cannot use the one that we typically use because it requires Java. So we're working on this as a team. The physics teachers are working on these assignments together. So that will be posted later this week. It's not up yet. And then the final assignment for the week. So that would be due Thursday. That should be a pretty quick one. There isn't a lot that you can do with the electric static charge sims that they have for that. So this should be pretty quick, 20 or 30 minutes at the most. And then due on Friday, yeah, you've got all of that up there, is another CER. Now, this one would be more detailed than the one that you're doing on Wednesday. You have a link to look at information about it, and then you have to put that into your own words. You have to use claim, evidence, and reasoning. And again, the chart is there, but it's the paragraph that you're being graded on. All right. And the same thing for this one. The chart is there, but it's the paragraph that you're being graded on. All right. So nothing is up yet in Google Classroom, but it will be by noon today. Let me see if I have any questions here. I'm here for close reading. Will you put the worksheet we usually use on Google Classroom? Yes. And like I said, I have made a copy for each student, so you don't need to download it or copy it to your drive anymore. You can open that document, type directly in that document, and then submit that. I know some people are doing handwritten assignments, taking a picture and posting them. If that's what you need to do, that's fine also. Are these all going to be linked on Google Classroom? They're all going to show up in Google Classroom at noon. Um, did anyone get Clever login? We're not using Clever. I know some of your classes may be using that, but that's because the district has purchased curriculum that's already loaded in that Clever, and that hasn't happened for physics, so we're not using Clever. I'm having trouble accessing Google Classroom on Clever. I'm not on Clever. So you're not going to get to the physics Google Classroom from Clever. I don't know about teachers that are using Clever. So, Eric, what is Clever? It's another platform similar to Google Classroom, but they have specific curriculum already loaded in that platform. So, teacher goes through that curriculum, those assignments, and can say, okay, let's have the students do A, B, and C, but we're not going to do D or F assignment. And so then they post A, B, and C as assignments for students to do. Okay, but we're not doing that because, like I said, they don't have any physics or science. Um, and I don't know how to join it. You will have to find out from your teacher. If your teacher is using that, then you have to find that out. I suggest going to the teacher web pages on the Pittsburgh High School site and go see what each of your teachers are saying you need to do. And if you don't find anything there, then email the teacher that hasn't given you information on how to do what you need to do. Okay, I know a lot of the high school teachers are using Google Classroom, but I understand that English and history. I'm not sure about Spanish or language, but English and history specifically, the district has purchased curriculum at the high school level on Clever. Middle school, elementary, I think it's a much broader spectrum that they have. How is everything going to be graded in GPA point system? It will be pass and fail. Okay, so you have to have at least a D. D minus is failing, but you have to have at least a D, and then you get the pass credits. I hope that you're striving for better than a D, but that's what you will receive on your transcript is either pass or fail. Okay. Um, so I posted three resources this week for you. One of them is for seniors, and that document says resources for newly admitted students. And so if you go and you click on that link, there's a whole document with all kinds of links for all types of colleges explaining what it is that they're accepting from transcripts from students. What is it going to be like as a freshman this August or this fall? Okay, so if you have questions about that, you can take a look at that document. There are two other resources that I posted for this week, and those are on static electricity. One has a few links on it, and as we get deeper into electricity, I'll be adding links to that list. And another is CER scaffolds, and we have used that in class when we've written CERs before. So I'm providing that for you as well. You do not have to use that, but if that helps you organize your ideas, then please use that. All right. And then also, I do want to say that these due dates, these are for you for pacing yourself. You should do this on Monday and Tuesday. You should do the next one on Tuesday and Wednesday. You have to do this on Wednesday. The sim is Thursday and this is Friday. But I understand that everyone has challenges with their situation one way or another. And any work from the week, and this will be going forward, that is turned in by midnight Saturday will be considered full credit. All right. After that, I'm going to start doing point deduction. But any of the work from the week, you have until midnight Saturday to turn in for full credit. But I'm putting due dates on these so that you know, oh, that was really due yesterday. I really need to get to that today. Okay. So that you can pace yourself. This week we're doing static electricity. Next week we're doing circuits, electric circuits. And then the following week we'll be doing electromagnetism. So that has to do with magnetism. It has to do with electricity as well. Now today I'm going to do a demo on static electricity, and Ms. Jacoy will also be doing a demo on static electricity today. She'll be doing Van de Graaff. So that will be one of the resources that you have to be looking at for information about static charge. And also the one of the CERs, you have a choice which one you want to do, will be on the Van de Graaff. So you may want to take a look at that. Van de Graaff, I love doing that in class. Students usually love having the opportunity to do that in class, but we can't. So Miss Kikoi brought it home so that she could do the video for that and she could post that. So I'll make sure to post on Google Classroom, her site. You can go to her site to see that. I believe she'll be posting that at 1:00 today, but I'm not sure what her time is that she'll be doing that live. And again, that's a Ms. Jacoy YouTube. But I will post that on Google Classroom so that you can get to that video. Full credit. Okay, so today I'll be going over balloon and static charge with balloon and a can. And Wednesday I'll be doing the static cat and lightning and how that involves static charge. You have Miss Jacoy's video that you'll be able to see on the Van de Graaff. And then Friday I'm going to go over clean rooms and laser printers. And that takes care of this week. And I talked about everything else on my list. So let's go ahead and take a look at how does the charge, the electric charge of an aluminum soda can and a balloon, how do those interact? So I'm going to have to reposition everything here. I want to get behind this balloon. Okay, so I have a couple of cans on a table there. I'll try to move that a little bit closer. I have to get behind it so that you can see what's happening. Whoa. All right. So here we go. We have a balloon and we have a soda can. Let me pop that up a little bit so the top of my head doesn't get cut off the whole time I'm there. If we want to see how static charge interacts between the two, so if I take this and I let go, there really isn't anything happening. The balloon is Not going anywhere because of the can. The can isn't going anywhere because of the balloon. Let's try this other can, see if there's a difference. Not really. The balloon is moving a little bit, but I had charged them up before. Now, what would I have to do if I wanted to get charge on my balloon? What do I mean by charge? I mean like static electric charge. Anybody have any ideas? When is school over? I don't know. I haven't gotten an official, whether it's still June 2 or if it's May 29. First Wednesday of June. Okay, June 2. Any ideas? How am I going to get a static charge on this? Well, actually, let's start with can. Let's see if we can put a static charge on the can. What have I got here? I don't know. My hair's going to stick up, and now the can's not flat. Here, I have a sweater here. Let's see if this is going to do it. The balloon is moving around. I don't know why it's moving around. Huh. That doesn't really seem to be doing anything. Okay, let's see if we can get some static charge on the balloon. Again, I don't know. I tried something that was fuzzy. This is a sweater of mine. It's actually pretty nice. I don't really want to get it all staticky. But nevertheless, let's see what we've got here. I don't see anything happening yet. Let's see if it'll stick to the wall. I see some wall here in the... No, it's not even sticking to the wall. Let's see if we can get it charged up some more. Oh, not really. My hair's getting charged up, isn't it? It seems to be sticking to that. Let's see if we can make anything happen this way. No, nothing's happening. The can's moving a little bit, but it's not doing what I need it to. And I got it to do this morning. Well, oh dear, this is horrible. Oops, I touched it. Well, I guess it's not going to do much. I really apologize. This will be the first time in all the years I've been teaching that I haven't been able to do this. Typically in class, we would look at my hair. My hair is certainly getting charged up. Typically in class, what we would do is have balloon hand races, and the winners get extra credit. And this isn't even moving, just barely moving. I rolled it from one end of this table to the other this morning. All right, I'll try another balloon, blow up another one at the end today, see if we can get that to happen. So what we need to do is talk about what's happening there. We can see my hair is standing up. Okay, so I want to talk about what's happening on the atomic level. So let's take a look at the atom. What's inside an atom? Anybody have any ideas what's inside an atom? What's in the very center of the atom? Okay, so we have the nucleus. Let me put the nucleus here. And what's inside the nucleus? We have subatomic particles. That's like submarine, so it's under, so it's smaller than. Subatomic particles. We have protons and we have neutrons. I'm going to stick to hydrogen here so that we can stay very simple. And what is the charge on a proton? Proton is positive. So I put a plus there for positive, proton, positive. They both start with P. And neutron is neutral, like a zero. It has zero charge, so I'm leaving that like that. I'll go ahead and do some labeling in a minute. Now, what is a subatomic particle that is outside the nucleus? We have an electron. And what is the charge on the electron? We have a negative charge on the electron. Electron has an N at the end. That's your negative. Now, there have been ideas about electrons orbiting the nucleus. And that's the way that your diagrams are given in your books. I really have a problem with that because we've known for well over 50 years that an electron is going to be in a space of probability. Okay, so, and that's called an electron cloud. So the way that I diagram them. Now, you do not have to do these notes. If you are a person that it is helpful to have notes to look at, I would be doing this in your notes. For me, I would be doing this. Now, I want you to label everything. So here we have an electron cloud. Here is our proton. Here is the neutron. This is the nucleus. And this is our electron cloud. Oh, nope, this is the electron. And this is the electron cloud. So that means that the electron in this electron cloud has a specific energy level. If it has a different energy level, if it has a lower energy level, it has to drop to a different level. So we can't have electrons in this space and be here in here that are different energy level, or electrons out here that are in a different energy level. There would be another cloud. So that's an area of probability where you would find an electron that has a different energy level than the electron that's here. Okay, so the electrons have to be at one level or another. They can't be at any random place. They're going to be residing in that place. When the electrons are excited, they receive more energy in one way or another. We'll go in this a tiny bit next week when we get into circuits. When the electrons are excited, they go to a higher energy level. And then when they drop back down to a lower energy level, that's when they release energy in the form of light. So that's what's happening with electrons. So now with the balloon and the can, the balloon and the can both start out with a neutral charge. They're sitting around minding their own business. They're neutrally charged. When I rub the balloon in my hair, then I'm trying to get charge on that. And that means that you can see by my hair is sticking up. So why is my hair sticking up? What has happened to my hair? The electrons in my hair have been pulled off by the balloon. So each of my hairs now has lost an electron. We have this electron and the proton in the neutral state. They cancel each other out. But if I lose an electron, now the object has more positive charge than a negative charge. The object did not gain protons, but there's more of a positive charge when you lose an electron. You have more of a negative charge on the balloon when it gains the electrons. And then if it's possible, you can, and again, I didn't have any luck with it this morning, you can pull the can along with that, but the can is still neutral. The can is still neutral. But you're pushing the negative charges on the can away, and it's not happening. So that's what's happening with that. And the electrons in a conductor, so we use copper for conductors, right? Electrons in our metals often are free to move around. So that makes them good conductors. Not all metals have the same affinity for giving away electrons. We call them electron donors when a material wants to give away its electrons, and we call it an electron acceptor or an insulator, like the balloon wants to take on electrons because of its chemical composition. So it has everything to do with the periodic table as to whether a material wants to hold on to its electrons or give them away. And sometimes, depending on the material that the object is in contact with, it can be an electron donor, and sometimes it can be an electron receiver or acceptor. So everything depends on the material that it's in contact with, as well as the periodic table of elements. Are there any other questions? Rub it on your head. I did rub it on my head. Rub it harder. Sorry, I tried. How long has this been going on? Um, I don't know if you're talking about electron clouds or if you're talking about the live. Uh, the YouTube live is 11:30 Monday, Wednesday, Friday, and that'll be the same this week, okay? So I don't have anything else to go over today. You can watch it again if you're just coming in and haven't seen what we've been doing. Have a good week, and the things in Google Classroom should be posted by now for this week. And like I said, the one for Thursday, still working on the PhET Sim, so that's not posted yet. Have a good week, and I'll see you Wednesday. Bye-bye. You know what? I'm going to blow up another balloon and see if I can get it to work. I can't believe I got it to work this morning. Um, but you don't have to stick around for that. Okay. Yay! Success! Oh, and you guys didn't even see that. Okay, sorry. I made it happen once and I didn't have the camera on it. Sorry.